Hey everyone, welcome to Never Stop Building. This is Jason here. This week I have for you instructions that go along with some plans for a simple set of timber frame mortise and tenon sawhorses that I made back in Colorado days. If you'd like the plans, they are available for free for Patreons or members of the channel. And they're available for purchase on the website, although I imagine it would not be too hard to figure out the dimensions from this video, just trying to offset the time I spend making these videos. So on to the build. These horses are designed to be made from rough sawn or dimensional 4x4 lumber here in the US, or you could use something like 90mm square stock. I'm not exactly sure what's available elsewhere in the world. Before you cut any of the joinery, you're first going to want to joint and plane the material down to square, uniform stock, and rough cut the material to the lengths specified in the plans. And you can do this with a big set of machines, but you could also, it could also be as simple as selecting really flat stock to begin with, and ripping it with a table saw down to size. For this, we chose red cedar from the hardware store as it was fairly low cost. It's pretty soft, so it wouldn't mar anything we put on these sawhorses. But it's also quite strong for its density and easy to work with. These sawhorses here and the plans for them are sized for a common shop height I have. So I have carts that are the same height. But this is simple enough. You can adjust the height for whatever your working position is or other tools or tables that you'd like to have sawhorses at the same height. After milling, do all the layout of your mortises and peg holes. It's worth taking your time on this process as it's really going to determine the fit and finish of the final piece. We're using stops in the machines mostly to make for repeatable operations, but if you want to do this all by hand with a hammer and chisel, it would be helpful to make a thin wood template or a story pole where you put the critical dimensions measured once and then transfer them to all the other parts. Double check your layout, and also it's a good idea to consider the peg hole layout. These are at an angle, they're diamond holes, which have a lot of strength, but regardless of what you choose, you want to lay out the hole on the tenons a little closer to the shoulders than the plans would indicate, so that you get a drawbore effect on assembly where the flex in the peg pulls the joint tighter. And this dimension is somewhat dependent on the type of wood you're using, so I didn't really put that in the plan, so this might require some experimentation to get right. A couple of millimeter offset should do in most cases. Always cut the peg holes first, as I'm doing here with the mortise machine. Similarly, you could drill with an auger bit from both sides and then use a chisel to clean up the corners if you like. Or you could just drill for both sides as a round hole and use round pegs, whatever your comfort zone and experience is. So while I'm cutting all the mortises, my buddy Fred is cutting the tenon shoulders on the table saw sled. This setup makes for pretty quick work of this process, but it's another area where careful handsaw practice can be gained. Similarly, you could use a right angle guide and a circular saw to achieve a similar effect. So it's obviously quite quick to use this huge mortise chisel to hog out the main mortises, but again, they can be chopped by hand or drilled and then chopped. It's important to cut the sides square and perpendicular to the mating face so that the mating parts don't twist or enter at an odd angle. You want to check that with a square as you are cutting. Another way to do this, a router with a guide bearing at the top of the bit is pretty great. What you do is you'd cut the first 1/4 inch or 6 millimeters of the mortise cleanly with a chisel. And then you can use a router with the bearing to follow that guide. Basically, you created your own template and you clean out the mortise and you finish the corners with a sharp chisel. When the mortises have been chopped to a consistent size, we're moving on to the tenons. So here we're using my homemade tenon cutting machine, which makes super quick work of the short cheeks And it's not big enough for the long cheeks, so that's where I'm using the bandsaw with stop blocks to cut the longer cheeks. You could do this all on a bandsaw, which is a super versatile tool. Also, you could do it by handsaw or some sort of table saw sled with the blade raised up high, although I would not recommend that. Table saws can be quite dangerous. The tenons should be cleaned and finished so that they have a firm slip fit on the cross grain sides and an interference fit on the long grain ends of the mortise. So that is, when you jam the tenon into the mortise, it should be tight in the direction that the tree grew, and not in a way that would split the tree. And for softwoods, you can just solid millimeter, or a 16th of an inch, or maybe a little less than 16 inches, can make for a very tight mechanical fit in addition to glue or pegs and whatnot. You use a little bit less for super hardwoods, and it's really the compressibility of the wood that will determine how much interference fit you use. The reason we cut the peg holes first is that because once you cut the tenon cheeks, all that initial layout is gone, and if you cut it now, the hole could blow out, so you sort of save yourself from having that. These legs have a decorative angle that's cut on both ends, and we do that on the chop saw. And then another angled cut in towards the bottom of the legs so that the sawhorses only have 4 points of contact with the floor. So this is going to help prevent any strange rocking. It also looks good. So I set up an angled fence and a stop on the bandsaw to make quick work of this. But easy enough, you can do this with a handsaw or I suppose a long jigsaw blade. You could also accurately trace out a layout and then cut both sides with a circular saw towards the center and clean up the waste in the middle. For finishing and final details, I like to chamfer most of the edges of the pieces. And these are basically sawhorses, so I wasn't going to hand plane everything, and we were kind of in a rush for another project. So we just left the machine planed finish. So you could use any finish treatment, any oil, any finish you'd like, really. And I'd encourage you to put in the same care into these that you would any future projects. Because if you fill your shop with quality supporting tools, you'll breed quality work. Also, while I'm doing all the finishing details, I'm going to use a chisel to chamfer all of the tenons where they would be tight, so that when they're inserted, it aids in assembly. So you'll note as I'm cleaning up and chamfering the pegs prior to assembly that there's this little kerf cut from the top of the tenon to the center of that diamond peg hole. This is to allow the tenon to expand without cracking in this type of joint arrangement. This is not necessary if you use a normal square peg that's at right angles to the tenon, or a circle for that matter. After you've made all your parts and checked everything, it's time for assembly. So for this, I start by assembling each of the legs first, pegging those joints, and then join them with the cross member, insert those pegs, and finally cap it with the top member and insert the final pegs. And after I got everything assembled, I made a thin, I didn't do that, you don't see this here, I made a thin wooden jig with a diamond hole in it so that I could put it over the peg and use a flush cut saw to trim the pegs to a uniform length. So all the pegs ended up being a little proud of the surface and the edges lightly chamfered with a chisel. Well, that's all there is to making a quality looking set of sawhorses. If you're already watching this video, you probably already have enough tools to make a go at this, so don't let all the big equipment stop you. Let me know what you think, and thanks for watching, and we'll see you next time.